Hey everyone, Rob here. Today I want to talk about threading in JavaScript. Uh, oh, excuse me. In fact, the fact that JavaScript is single-threaded, one thread of execution runs at a time. And this has caused some confusion with some people. In particular, I had a coworker, and this is a very familiar conversation. She had some JavaScript code, and she had some stuff set for asynchronous execution, and it didn't actually execute when she expected it. And she's scratching her head going, what's going on? And the answer was, well, JavaScript was busy doing something else at the time. You need to, it basically needs to have some time to run your stuff. So this is actually a pretty simple concept, and a quick demo can actually show this pretty clearly, how it works, and get you thinking in the right mindset so that you know how to deal with these issues. So let's go over to our console, and let's go mkdir, make dir, async sounds good. So we're going to go into this directory, and we're going to create, we're going to use Visual Studio Code. So Visual Studio Code, just open this directory. Nice. So what do I want to do? I'm going to create a file. We'll call it test.js. And let's start by doing something very simple. Console.log hi. And let's run that. I'm going to go node test.js, and it does exactly what you would expect. And also note that what happened was it console logged this out, and then immediately finished. It terminated the application. It knew that it was done. So next thing I'd like to do is add something that has delayed execution. So I'm going to create a function called hi2. And what's it going to do? It's going to do set timeout, set timeout, and so we're going to call set timeout, and we're going to at a later time run console.log hi2. Okay, pretty simple stuff. We do need to tell it how long to wait. I'll wait 1 second, so it's obvious. Now first I'll run this without actually calling hi2. So let's go down here, and what's going to happen is the function is declared, and then we console log out hi, and then that's it. So test, yeah. So it never actually called hi2. Okay, next thing we do is we'll call hi2. So pretty simple stuff so far. But let's think about what's happening here. Well, first of all, demo. Always easier if you see it. So hi, and then wait, and then hi2. It's exactly what I expected to have happen. The program started up. It saw a function declaration. It does whatever JavaScript does. Then it called hi2. Okay. Calling hi2. What did it do? It called set timeout. So it called set timeout, and then it passed the parameters. It passed something that says, hey, here's some code to be executed later, and here's the timeout. But it doesn't actually execute that later. It just gets queued up somewhere. There's some event queue that it was eventually going to process this for us. And it's scheduled for execution in about 1,000 milliseconds. So that's how it works. And then finally, we called console.log. Right? So our application started up. It wrote out console.log. A second went by, then hi2 executed. Now we're going to do something a little nasty. Now I'm going to tie up the main thread of execution so that it'll never have an opportunity to process things in the event queue. Okay, so easiest way to do this is while true, do nothing. So now we'll run it again. And I got my high. And, oh, excuse me. And I never get high 2. And that's to be expected if you understand how this works. This is queued up, and soon as the system has time to process the event queue, it will process this, but right now it's stuck, so our main thread of execution is stuck, just doing nothing. So let's stop that. Now there's a little trick. It's not really a trick, but there's a technique that you should maybe know about. There are times when you do have to do things that will take a long time, and you do want to give your JavaScript the opportunity to process things that are queued up, that are ready to run. So one way to do that is as follows. So I'm going to hang this up, but I'm going to hang it up in a different way. So let's do this. Let's create a function called callSelf. Okay, and what's callSelf going to do? It's going to set a timeout. Set timeout. Thank you. As before, and it'll just call self, right? And how long do we want to wait? We want to wait 0 milliseconds. We want to do it right away. So this looks like it'll hang, and it will. It will hang, but the way it hangs is slightly different. Oh, and I forgot, finally, haha, I do need to call myself. So I need to start the whole ball of wax running. Call self. There we go. So now, like I was saying before, this will get stuck. However, it gets stuck by putting things in the event queue. So think about this. We'll execute, same things before. We'll execute our console log high. We'll call self. What'll that do? It'll call this set timeout. And it'll execute the set timeout right away. And then queue up something for execution later. And what's a queued up for execution later? It's, well, call yourself. So it will get stuck in this loop, but it's sticking, it's going through the event queue now. Now it's going through the event queue. And if there's something else on the event queue, it'll have an opportunity to run. So now, when I run this, I see high. I see high 2, and then it's stuck. So because even though we've put this, this nasty lockup function at the end of our application, we're going through the event queue. Everything's going through the event queue. And by doing this little trick here, we've given it an opportunity to process other things in the event queue. If I had other things in the event queue, they could run. So that's basically it. So I hope you followed this little tutorial. It's fun thinking about this stuff. And let's see, where Control C. Control C, we're done. Have a good one. Thanks for joining. I hope that was useful.